Good morning, everyone. Today, first, remember your assignment due tomorrow, so you have 2 days to work. Any question, please send me an email today. Probably tomorrow I am not going to be answering emails, so any questions, send me an email today. For the lecture today, you are doing software. The next step, the quality. What do we do in order to measure the quality of your projects? What do we do in order to know which of the solutions that you are going to submit tomorrow is higher or lower quality? There are a lot of things that we can do. I am going to describe the first one, the easy ones, the first steps. There are some metrics for the quality of the software. Metrics, we need to put numbers when we try to evaluate something. If you want to know that something is good or not, you need to compare that something with another one, an ideal version. And the best way to make a comparison is having numbers. Numbers for one, numbers for the other, compare the numbers. So you remove to some level the subjectivity. It's not I like it or not. It's about these are the numbers. Which numbers we can use? Well, there is a big collection of software metrics. I am going to introduce the traditional ones, the simple ones, the ones that everyone can use without a problem. And later, we talk about others, a little bit more complex. But for today, the easy ones. Measure the quality of your solution. Now, when you measure the software, one thing that you want to do is all about quality. These numbers that we're going to describe, these metrics, are because we want to measure and compare the quality of the product between diverse solutions. Now, another thing that happened indirectly is these numbers are also measuring the work done. Some of these metrics are not going to measure only the quality of the final product, the software, but somehow, indirectly, what is happening with the team that is developing that product. The skills of the team, the amount of work that they did. Each of these numbers is connected with quality. Some of them are connected with the skills in the team. Some of them are connected with the time that they use, the work that they are doing. Which are these numbers? Well, metrics. Let's talk today about 3 categories of metrics. Metrics for the size of the product, how big is the product. I am talking about the product, the software, when the software is finished, when you already have a version to measure. All of this is not about prediction, but about measuring something that exists. For instance, we can measure what you submit tomorrow and talk about it next week. Anyway, size, metrics for size. I am sure that you know lines of code. The traditional way to measure the size of a piece of software is how many lines of code are involved in that piece of software. Now, I want to talk about 2 categories. We can measure lines of code. We can measure logic lines of code. And I am going to talk about the difference between those 3. So, size, lines of code. Another thing that we measure is understandability. How easy is to understand that software? And I am not talking about start reading and making a survey about I like it or not, I was able to read or not. Numbers. The theoretical background tells us that a piece of software, like any other document, is going to be easy to read if everything is explained. In terms of the code, comments. How many comments do you have in your software compared with how many lines of code you have? This relationship between lines of code and comments is going to help us to know how easy it could be for a standard people, another programmer, to understand what you did. This is going to be connected with another metric, but for this one, comments and lines of code, the relationship. You can be thinking like, well, some programs, even though have the same numbers of lines, is not the same a hello world that's something more elaborated. And you are correct. We're going to connect this understandability metrics with the complexity metrics. They are going to be correlated. For understandability, comments, also white spaces. It's easy to read something that have a good balance between the lines that are doing something and some elements that help you to read easily. Tabs, white spaces, enters. Something that you measure in a piece of software is the relationship between how many white spaces you have, and I am including here the tabs, the enters, and so on, all these characters that do nothing in the code but help to organize the code. How many characters of that do you have versus how many characters in total do you have in the document? I am not talking here about the lines of code. I am talking about characters. We make an addition of every single character that is valuable and how many white spaces, enters, tabs, whites, and what is the relationship between them. And don't worry, you do not need to count that manually. There are software that we're going to review that basically give you these numbers. The idea is that you understand the numbers only, but the software is going to do the counting. Now, moving forward, complexity. How do we know in a first step the complexity of the software? Well, this is something that hopefully you already reviewed. You know about cyclomatic complexity. So we can use that measure. You already know how to calculate this. I am going to do a quick review, but metrics for complexity, the first one, when you mention this, is cyclomatic complexity, the traditional one again. So for cyclomatic complexity, talking about this, you calculate cyclomatic complexity for every single method. And then if those methods are in one class, you document for that class which one is the higher cyclomatic complexity. Use the number. We do not care exactly which is the method, but in that class, which is the higher cyclomatic complexity in one of the methods, and the average. Usually we're going to be handling this maximum and average. The minimum, well, is not relevant. The top of the complexity and the average of the complexity. And we're going to start with the cyclomatic one. Now, with the cyclomatic, another thing that we need to talk about is, well, the complexity of the connection between the classes. And here, this is something that we did before. The complexity measure like the lines that go in and the lines that go out, instability and abstraction. And we are back with our chart, the pain zone and the useless zone. We can put all of this together, and with all these numbers, we have elements, fingerprints from one software, from the other, and we can basically do a comparison of the population. These ones, the easy traditional metrics. We need to move to others, but for today, this is good enough to review. Now, just to be sure that you can calculate this manually. Again, in the practice, you're going to use software, but for your exam, just to be sure that you know the concepts, we can ask you to calculate this for a small piece of software. Concepts. Let's start with the size metrics. For the size, just to be clear, LOC, lines of code. Lines of code, we are talking about everything, obviously except the comments, everything that is part of the program. Now, for the lines of code, something that happened is if you follow this notation, or if you follow this notation, that is going to impact the number. For the lines of code, we do not care about the content of the line. As far as the line is part of the program, the line is going to count. So for instance, here, I could say that I have 2 lines of code. Yeah, this curly bracket is going to be counted as a line of code. Sorry. And here, 3 lines of code. The system, the software is going to count lines that have something that is not a comment. 2 versus 3. Yeah, you're increasing the size here with garbage, but that is going to be solved by the other metric. Lines of code, anything, not comment yet. So easy. The numbers of lines in your classes in the full system is going to tell you an idea of how many hours a programmer work or a team work. Question for you guys. How many lines of code per hour are okay for a programmer, a professional one, in any project? Lines of code per hour in programming. Any idea? Any guess? Too high. Think about this. We're talking about the generality. Okay, we're improving. We're talking about the generality. We're talking about for solving any kind of problem that could be easy, complex, reading, documenting, and so on. It's going to depend on what we are doing. I am agree with that. I am mentioning that, depending on the software. The average. You go outside, make a survey, ask to 1 million programmers, and according with this, it's not my number, it's from the textbook. 10 lines of code per hour, useful lines of code. Why I mention this? I do not want you to use this in your project because you are going to tell me that you need 1 month to finish your project. I am pointing out the fact that in 1 line of code, you can spend a lot of time because the difficulty in programming is solving the problem, not writing the line. Think about these recursive methods that do the traversal of a tree. The recursive method for printing a tree in pre-order, post-order, and so on. How many lines of code there? 3, 4, 5 if you count the curly brackets. 5 lines. You really did those 5 lines in half an hour? I mean, you understand the concept there the first time that you read that code in half an hour? Probably not. You spend at least 1 lecture, 75 minutes. 10 lines of code, average, because you have no idea about complexity. The projects outside, and for sure are not going to be print hello world. So an average, 10 lines of code per hour. But obviously, it's depending on what you're doing. For your project, your homework, you do not need 10 lines of code per hour. You can do more. You can be close to 50, 100, I am sure. It's not so complex. Anyway, lines of code. Anything counts. 3, 2. Bad idea counting everything. So we create another metric, effective lines of code. And usually you're going to read these letters. ELOC. Effective lines of code. You know what? Measure everything, but well, we already ignore the comments that is outside, but also ignore any line that is basically a parenthesis, a bracket, or empty. So honestly, the only thing that we are ignoring here is cases like this, the brackets, or something similar with parentheses. The number of lines of code here is 3, but the effective ones, the ones that have something important in which the programmer spends some time, is 1. I am not counting the brackets. And if I go here, well, it's also 1. I don't care about this bracket, and this bracket is in the line that I am already counting. So lines of code, 3 and 2, effective lines of code, 1 and 1, the condition one. And I do not have a body, so use one effective line of code. Things are going to become more interesting because for some people it's like, well, you know what? The lines of code that are really important are the ones that do something. And this if, well, this if is only creating two paths of execution, but execution of what? We're going to move to another, but quick parenthesis, usually we prefer the effective lines of code versus lines of code because, again, according with the author, excuse me, the difference between lines of code and effective lines of code is the lines of code, counting the brackets, is going to increase the size of your project like 20, 40%, depending on your style, right? Depending on what you do. Here, obviously, is more. If you decide to put every single curly bracket or parenthesis in a different line, here it's going to be a little bit. So 20, 40%, again, an average statistics in your project. Effective lines of code are better, even though we still use lines of code, this one, the one that count everything, as the main measure of the size of a program. This is the one that you're going to find mentioned in every single place, in every single book or line on the internet, lines of code in general, without identifying anything else. But this one is better. Not yet. I am going to talk about that, the if condition. So here is use the line. Here, the condition can be whatever. It can be true, or it can be a long list of variables with relational and logic operators. Is one line. Now, the complexity is the one that is going to help us with the identification of two different cases in which we have one if with a long condition, or two if, one inside of the other, that basically are doing the same. Effective lines of code. Next step. You know what? I don't care about your lines. The only lines that are important for me are those lines that are doing something. And those lines that are doing something are instructions. And in languages such as Java, C, or C++, the lines that are doing something are those lines that finish with a semicolon. So I want to count those lines, the lines that finish with a semicolon. Quick parenthesis, you're going to tell me, well, in the for loop in Java, C, and C++, we have semicolons. Okay, yeah, and you have two semicolons. Yeah, you have two semicolons. However, that one is going to count like one because it's one instruction. For one instruction, it has semicolon. Okay, we're going to count it, but not two times, even though it's using two semicolons. It's a special case. Is going to count like one instruction, one important instruction. However, as you can notice, the for is going to be checked because the semicolon, the if condition is not. Yeah, that is what I mentioned. Java, C, and C++, and my measure of the semicolon. Other languages is not going to be the case. In Lisp, we will be counting comments. If we think about the semicolon is the character to open a comment. So different ideas, right? Logical line of code, the things that do something, Java, C, C++, the semicolon ones. For is going to count, if, no. Okay, so if I have an example like this one, trivial example, an if condition with some curly bracket, one instruction, and a comment. I want to be sure that we agree lines of code, line of code, the bracket, lines of code, lines of code. If we measure LOC, how many lines of code do I have in this small program? Well, I have 4 lines of code. That is what my programmer did. And yes, if you put this curly bracket here, you are eliminating one line of code. Sorry, the metric is used like that. It's a very naive metric. We're counting the comments in a different way here, separated, because we're going to do something with those numbers. So for the scenario that I am describing, for the things that we're going to do, please note, the comments are lines of comments. We're going to have that metric, lines of comments, and the lines of code are not going to include the lines of comments. So here, use for. You can add more comments. It's not going to increase the lines of code, but you can add curly bracket, parentheses, those things, even though they are empty, they are going to count. Now, effective lines of code. The effective lines of code, as we described, every single line except those curly bracket, parentheses, and so on that are alone. So in this scenario, I am going to eliminate this one, it's a curly bracket alone, and I am going to eliminate this one, it's a curly bracket alone. So effective lines of code, here I have the if one, and I have the equation, y equals something. Effective lines of code in this program, I have 2. And you can imagine here that you can do a relationship between lines of code and effective lines of code, and that is a measure of how many garbage one person or one team put in the code. It's a number, and you need to be careful with the number. The number is not going to tell you this team is putting a lot of garbage in the code. The number is just going to give you a relationship, and you need to do an analysis depending on the people and depending on the project, if that number, a lot or a small number of garbage, makes sense or not. Here, I am moving a little bit to the statistic part. I am showing you how to get the numbers and how the numbers are obtained. But remember, the analysis of the numbers and what is the message that the numbers are telling us need a review of the particular case. So I cannot tell you that the relationship between lines of code and effective lines of code should be a ratio of 20% or 40% or whatever, or that above 40% is bad and below is good. Those thresholds, magic numbers, do not exist. The numbers should be analyzed case by case. The numbers just allow you to compare populations. That's it. For instance, for your projects, I can calculate this for the projects of different people, and it's the same project. You are in the same class. You learn the same background. We can use these numbers to compare and go inside and review the details of one project and another one. Maybe one with a lot of lines of code and another one with very few lines of code. What happened here? What is the difference? Whatever. Moving forward, logic lines of code. In this scenario, as I mentioned before, we're searching only for the semicolon. So in this case, I have basically only this instruction that is considered important in the 3 cases. It's a line of code, it's an effective line of code. Moreover, it counts like a logic line of code. It's a line that is doing something, and the if is not going to count. A for, yes. An if, not. A while, not. And the if is counting not because the condition. The if is counting because the increment that have at the end. That is the part that we're counting. The variable, if you want. The conditions, split the paths, are important for the lines of code, for the effective lines of code, not for the logic. This is 1. My numbers for this small piece. Now, comments, well, we count the comments separate for one reason. This is obviously a line of comment and it's going to count, but this line, you can put in the same line a comment and an instruction. If we measure this as a line of code, it's going to count like one line. However, if we count the comments separate, we have in the same line comment and instruction. Later, usually, what we do, line of code plus line of comments. And that number is going to be, some cases, bigger than the physical number of lines in the file, because cases like this. The important thing, we are measuring or we're considering that the programmer that did this first line, for instance, spent some time figuring out the if and the condition, but also the comment. Theoretically, there is a timing, a mental process to figure out which is the comment that I am going to put here, which is the comment that best explain what I am doing here. So lines of code plus lines of comments, and that is going to be a representation of the amount of work, and we're counting separated the comment in the line and the line itself. So lines 4, comments 2, you can make the addition, and lines of code and comments could be a total of 6 that represent the maximum number in the table for the effort. And 1 line empty. I am going to talk about the empty lines in the understandability part. So hopefully this is clear. Lines, everything, effective, everything except the curly brackets, the parentheses alone, and the logic, search for the semicolon, 3 numbers, and the comments. Good? Great. So lines of code per method. And this is just, again, a recommendation and a statistic. Usually, when you're creating a method, inside of a method, how many lines of code do we have? How many lines of code are good inside of a method? Global numbers, not mandatory, but in general, the people mention this. If you have a method and your method have around 20 lines of code, that is very good. Lower than 20 is a method that probably should not be a method, probably should be added with another thing. Again, this is probably, this is something that you need to review. It could be a constructor, and the constructor is initializing only one variable, therefore you have only one line. Nothing can be done in that case. In other cases, maybe you have a method that is calling another one, and that another one is doing one thing. Well, that one thing can be added to the original one. Red lights, you need to review the case. Anyway, 20 looks very good. 50 is twice the previous number, more than that, but still could be okay. 100 in a single method. That 100 in a single method is asking you for, can you split this in more than one method? It's kind of a yellow light. You can improve this. More than that, more than 100, and I am just giving here 150, but it's more than 100, is usually considered a bad idea. It's not anymore a suggestion for improving, it's more like, please do something here. And if you reach something like 200, 250, it's like, this is no good. Why? Why do you think that these are the numbers for the size of a method? What is the criteria? Any idea? The key is the human brain. The human brain, tell me, how many lines in one page? How many lines do you have in a page, a usual, in your notebook or in a book? More or less around that, depending on the font, depending on the size of the page. You can tell me several different things, but it's going to be 20, 30. Okay, a small font, maybe we go to 50, very, very hard, but more or less. 2 pages. Usually, the consideration is your brain, the human brain in general, average. There are cases, outliers in both extremes, but usually for your brain, it's going to be easy to remember the content of 2 pages. You can be reading 2 pages and understand perfectly where the information is in those 2 pages. Reviewing a method. Remember what a method is doing from the beginning to the end in 2 pages, 50 lines. At the top 100 lines is easy. We can trust that the developer knows what is happening there. If we move beyond those 100 lines, or 40, or a number between these, the theory is one programmer, one human being is not going to be able to deal with the complexity in those lines. So one person is not going to be able to handle that method. When we ask the developer to split the method, and instead of having 1 of 100, having 2 of 50, or a combination there, what we are asking is the same things that we do in a textbook. We split the book in chapters, the chapters in sections, the sections in paragraphs. And when you read, you're reading one paragraph, you forget the others. You are focusing one small paragraph. And there is also a rule regarding how many lines in a paragraph, right? So think about that like this rule about how many lines in a method. Your method are like the paragraphs in your document. Use as an analogy. So 20, good, 200, bad, and a scale with numbers in the middle. This is about lines of code. I am talking about lines of code, not effective, not logic, lines in general. This is 3 and this is 2 for the limit. So that's it. So this is regarding the size. Let's check the understandability. For the understandability. Very simple. And I give you the context and the explanation, but what I need you to remember and check is this equation here. Lines of comments. How many comments do you have? How many lines with comments? And how many lines of code in total? The relationship between those two is going to be a measure of understandability. Yeah, we can make this a percentage, so the 100, but the measure here. For instance, in my previous example here, lines of code 4, comments 2. What could be the result of my equation? 4 lines of code and 2 comments. The percentage, the relationship is comments, lines of code, half of the program is comments, right? 50% of lines of comments. That is what the number is going to tell me about my previous example. Question, guys, good or bad? 50% of a program is documentation, comments. That is great, perfect, or something is wrong? Okay, great. I know that in CSI 110, when you start learning programming, they told you, please put comments. Comments are your friends. Use the comments, and they motivate you to put comments. You're learning to program, right? So we need to motivate you to use good practices. But any good practice can become a bad practice if we abuse. In this scenario, having a program and having this 50% relationship between lines that are doing something, lines of code, and the comments is really bad. In general, you cannot have so many comments. And this is something that you are going to learn in a different class, in a different scenario, but the best source code is the source code that do not need comments. The best source code is the one that explains itself. Sometimes you need comments, yes, sometimes you need comments, but the number of comments cannot be so high because this programmer is using 50% of the time putting comments. And remember, you're paying that person. So half of the time is for documenting things, documenting its own code. So you do not trust that your code is good enough for others to be understood without the comment. That could be a little bit of the analysis with the number. In general, I am not telling you that you should fire this programmer. I am telling you that this number, 50% relationship, is a red light there, and you need to review what is happening. Maybe the program is machine learning stuff and is very, very complex, and really you need to explain line by line. And in a worst case scenario, you have a relationship of one-to-one, one line of code and one comment. It's a special case. The number is going to tell you red light, review what is happening, evaluate if the problem is worthy this relationship. That's it. Similar to this, and again, I share you the information, but the important part is this equation. This equation, you are not going to do this manually, but we are going to use software next week for doing this. As simple as this. How many spaces do you have? How many characters, spaces do you have in your program? And I am counting here the tabs, the enters, and the real white spaces, anything that is not visible on the screen. Those white spaces, how many of them do you have? And the total number of characters in your program. And just to be clear, the total, I am talking about the white spaces that we already measured and the other characters. Every single character, how many characters in your document? It's a document, your program. How many characters do you have? And how many of those characters are white spaces? And similar, we're going to transform this to a percentage. So the percentage of white spaces in your document. Good. The percentage here, the percentage of white spaces. Yes, the number of, number of spaces divided by, the parentheses there. Thank you. So a percentage. The percentage here is going to give you an idea of how easy or how hard it's going to be to read your program. The idea, if this percentage is low, then you have a small number of white spaces. Then you have all your program like in a few lines, no enters, or like your equations, your operations, and your variables are together. All this is going to save white spaces, but all of that saving white spaces is going to make things hard to read. Hard to read for the human eye. Think about it. You are reading a book, everything is, or you have spaces and bullets, things like that. Using usability metrics, usability background is more white spaces, easy to read, easy to understand. However, it should be a balance between, okay, this is for you to make this easy to read, but you cannot have all your program in double space, right? A balance again. And we're going to calculate this probably for your projects next week. Okay, so in general, the percentage of the white spaces, the percentage of the comments, and for the lines of code, what we're going to do is an average of lines of code in a class, the maximum line of code in one function in your class, and the minimum lines of code in one of the methods in your class. So you have a class, and I am going to count per method the lines of code. I am going to have a measure of how many lines of code do I have inside of a method. That is the number that is important. I have a particular number of lines of code inside of each method, so I can calculate the average, how many lines of code per method in the class. I can calculate, or I can know the maximum number of lines of code in one method. I don't care about which is the method, but which one is the maximum number of lines of code in one method. And used to complete this, the minimum. Usually the minimum, you are looking for something to eliminate, but the maximum is something to care about it. And the average is the one that is going to help me to compare this population, this class, with another's, like the same class from a different team, like your project. Good. So next one, complexity. The good thing is you already know this one, complexity, cyclomatic complexity. I am sure that you review in 360 all the background of this. The only thing that I need you to remember is how to calculate the cyclomatic complexity of a source code that I give you. For instance, cyclomatic complexity of the example that I showed you before with one if condition. What is the cyclomatic complexity of that example that I showed you? One if with one line inside. Answering the question in the chat, yes, the number of white spaces include the enter, so every single new line is considered one white space, this enter in each line, yeah. So cyclomatic complexity of the example that I showed you before, cyclomatic complexity of something like if, whatever, something here, whatever, 2, yes, thank you. So cyclomatic complexity, you review all the background, all this idea of the control flow graph and blah, blah, blah. The only thing that I need you to remember, as usual, the blue equation, cyclomatic complexity of a piece of software, you calculate this per method, right? So the cyclomatic complexity of your method is going to be something like the number of conditions plus 1. In my previous example, I have one if, one condition, right? Plus 1, cyclomatic complexity, 2, correct? Cyclomatic complexity, why the conditions? Because the conditions are the ones that split the flow of the program. Every condition is split in 2. And that, several different paths of the execution. Different path for testing. You need to test all the branches, right? Well, coverage, a different thing. That is the traditional measure of complexity in the software, the number of different paths that are created. And the easy way to obtain that number, that measure, is 1 is the complexity of everything that is sequential. So 1 plus any condition that you add, and that gives you a number. That number, the cyclomatic complexity, or the McCabe number. The author of the guy that have the idea of this calculation. So McCabe number, cyclomatic complexity value, depending on the textbook, the names. You calculate that in this way. So we calculate cyclomatic complexity per method. And because we calculate cyclomatic complexity per method, we're going to have exactly the same that we have before with the lines of code. Per each method, we're going to have the cyclomatic complexity. So inside of a class, we're going to look for the maximum cyclomatic complexity inside of that class. We're going to look for the minimum cyclomatic complexity inside of that class. And we're going to look for the average complexity of the class. The addition of all the cyclomatic complexity divided by the number of methods, the average. Complexity, size, and understandability. We will have numbers for that like this. A report of your project, a fingerprint with a bunch of numbers, percentage. And if I put here the numbers for another project, 2 solutions of the same problem, your solutions for the project that you are doing, the fingerprints, 2 things that are too similar, good, differences between people, differences between programmers. What about 2 solutions that are noticeable different? One is too high, one is too low. That is going to suggest something to review. And probably we can do that next week. Anyway, Just as I did before, the number of lines of code per method, I show you a recommendation, the cyclomatic complexity per method, used as a recommendation. I think you already reviewed this, but just to be sure that you remember these numbers as a threshold. 1 to 10, happy face is like usual, normal, trivial. 1 to 10, nothing happened. 1 is sequential execution. Having 10 is like, well, there are 9 conditions here. Not so bad. It's great, perfect. If you move forward, when you go above 40, I am talking about 39 conditions. That is a problem. That is a sad phase. And it's a sad phase because, again, it's complex. Why we think that it's complex? Think about the unit testing. Think about the testing for that particular method. We're talking about numbers per method. These are one method with those measured. One method with a complexity of 40 or more is going to be very, very painful to test. And it's a red light for refactoring things. Anyway, those are the metrics. We continue working with them next week.